All right, let's jump back in time, way back, about 1,500 years, to meet an absolute giant of the ancient world. This is a guy whose mind literally reshaped how we think about numbers and the entire cosmos. Wow. I mean, when Albert Einstein says something like that, you know it's a big deal. He's basically saying that without the groundwork laid by ancient Indian thinkers, modern science, as we know it, well, it just wouldn't exist. And that really sets the stage for the person we're talking about today. Seriously, think about that for a second. In the 5th century, one person decides he's going to tackle the biggest puzzles in the universe. And what did he have to work with? No supercomputers, no fancy telescopes, nope, just his own brain. It's pretty incredible. This is the story of a true master puzzle solver. So, who is this puzzle master? His name is Aryabhata. He was born way back in 476 CE, and he really kicked off this incredible tradition of mathematician astronomers in India during its classical age of science. And this is his masterpiece, the Aryabhata. Get this, it's a huge collection of math and astronomy, but it's written in just 108 short verses. He covers everything from basic arithmetic to algebra and trig. I mean, the sheer efficiency of that is mind-blowing. It's no wonder people studied it for centuries. Okay, so how exactly did he start cracking these cosmic codes? Well, like any good detective, he started with the fundamentals. It all began with numbers. He had to build this rock-solid mathematical foundation first. All right, let's talk about the puzzle of, well, nothing. The idea that nothing could actually be a number, a concept, was totally revolutionary. Now, he didn't use the little circle symbol for zero that we use today, but his whole system of writing numbers, the place value system, it depended on the idea of a placeholder, to tell the difference between 1, 10, and 100. So the concept of zero was baked right in, and it was the key that unlocked all his other complex calculations. Okay, here's a puzzle that has driven mathematicians crazy for forever. It sounds so simple, right? How do you perfectly measure a circle? And this is what he came up with. 3.1416. Just let that sink in. He calculated this in the year 499. To get pi accurate to 4 decimal places back then, it's just stunning. So here's how he laid it out. Add 4 to 100, multiply by 8, add 62,000. And that gives you the circumference for a circle with a diameter of 20,000. But here's the really brilliant part. The word he used was asana, which basically means approaching or approximately. This tells us he knew this wasn't a final, perfect answer. He understood that pi was, well, irrational, something you can only get closer and closer to. And he figured this out 1,200 years before European mathematicians proved it. Incredible. All right, let's move on to an algebra puzzle. How about this? Can you think of a single number that when you divide it by 8, you get a remainder of 5? And when you divide that same number by 9, you get a remainder of 4. I mean, where would you even start with a problem like that? Well, Aryabhata had a method for it. It's called the Kutaka method. And the name literally means to pulverize, which is just perfect because that's what it does. It takes a big, messy problem and just smashes it into smaller and smaller, more manageable pieces until you can solve it. It's this super elegant algorithm, and believe it or not, variations of it are still used today in things like modern cryptology. Yeah, ancient math protecting your digital secrets. So after mastering the world of numbers, Aryabhata turned his attention upwards, to the sky. He wanted to solve the great puzzle of the cosmos. And at that time, there was one huge question. Do the heavens revolve around us? For centuries, pretty much everyone believed that the Earth was the fixed center of the universe. It was the accepted truth. But Aryabhata? He had a different idea. And frankly, it was a pretty radical, even dangerous one. And the way he explained it was just beautiful. He used this perfect analogy. He said, look, if you're in a boat moving down a river, the trees on the shore look like they're moving backward, right? He said it's the exact same thing with the stars. They only look like they're moving west because we on Earth are the ones who are actually spinning. It's such a simple, clear explanation of relative motion. And this wasn't just some philosophical thought experiment. Oh no, he backed it up with math, hardcore calculations. He figured out the length of a sidereal day. That's how long it takes the Earth to spin once relative to the stars. And just look at these numbers. His value was 23 hours, 56 minutes, and 4.1 seconds.
The modern value? 23 hours, 56 minutes, and 4.091 seconds. He was off by less than a tenth of a second. That is just staggering for the 5th century. He took that same scientific brain and pointed it at eclipses. Back then, the common belief was that eclipses happened because mythical demons were literally swallowing the sun or the moon. But Aryabhata just cut right through the superstition. He said, nope, it's just shadows. A lunar eclipse, that's just the moon passing through Earth's shadow. A solar eclipse, that's the moon's shadow falling on the Earth. Simple, elegant, and correct. This was a huge leap from myth to actual science.
So you have this incredible body of knowledge. But how did it last? How did it spread and influence the rest of the world? Well, it's a legacy that's written not just in ancient texts, but, as we'll see, in the stars themselves. You can see this journey in the history of a single word. You know the term sine from trigonometry class? Well, it all started with Aryabhata's Sanskrit term ardha for half chord. Then Arab scholars transcribed it as jaba, but then a later scholar mistook that word for jibe, which means fold in a garment. When that was translated into Latin, it became sinus, which means cove or fold. And from sinus, we get sine. It's like a 1,500-year-long game of telephone, showing how one idea can travel across the entire world. Okay, now let's jump forward in time, way forward, over 1,200 years. The year is 1765. There's a French astronomer named Guillaume Le Gentil in India. He's there to watch a lunar eclipse, and he's got all the best, most modern European star charts with him. But as he's setting up, he realizes something's not right. He finds out that the local Indian astronomers, who were using methods based directly on Aryabhata's work from the 5th century, had a better prediction for the eclipse than he did. Let's look at the numbers. Le Gentil's fancy European charts were off by 68 seconds. The ancient Indian methods, off by only 41 seconds. The 1,200-year-old math was more accurate. The ancient master beat the modern science of the day.
And that legacy, it's everywhere you look. His work got translated into Arabic and was a huge influence on the Islamic Golden Age. His math is the basis for the Jalali calendar, which is still used today in Iran and Afghanistan. When India launched its very first satellite in 1975, what did they name it? Aryabhata. There's a crater on the moon named after him. They even named a species of bacteria found way up in the stratosphere after him. His influence literally stretches from ancient history right into outer space.
So we're left with this thought. If a single person with just their mind could figure all of this out in the 5th century, it just proves how powerful the human intellect can be, no matter the time period. And it really makes you wonder, doesn't it? What other incredible knowledge, what other secrets are just sitting there, waiting for us to rediscover in the wisdom of the ancient world?